All right, so today we're going to be doing domain range, a section 2.8. Domain and range are ways to describe where a graph exists. Okay, so like if I draw a picture, I can identify where it exists by giving it a domain, meaning like how far left does it go, how far right does it go? And I can give it a range as well, how low to how high. Okay. So we're going to get into that in a bit, but how to identify a function graphically is going to be the first thing we're going to do, okay? Because they're going to be asking you questions about is the following a function, yes or no, okay? So let me kind of highlight that word, how to identify a function, okay? Now, there's a couple of different ways you can do it, but the easiest way is the way we're going to do it, okay? And it's basically based on a picture. We use what's called the vertical line test. So use the vertical line test, which says okay, so we're going to use the vertical line test. So how do we identify a function? We're going to use the vertical line test. And the vertical line test basically says, and right now I'll write it out, but it says if you draw many vertical lines on a graph, if you draw a bunch of them, and each vertical line only touches the graph once, at one point, then it's a function. Okay, the graph that you were crossing over will be a function. Okay, so again, what does it say? It says if you draw a vertical line, or let me say many vertical lines, so if you draw many vertical lines across the graph, and each one only touches the graph once, then the graph is a function. I'm going to go ahead and pause the video just to give you guys some time to write this down. All right, so let's go ahead and test some of these things, okay? These do not have to be drawn perfectly, okay? Just draw something that's similar. It doesn't have to be identical to mine. Notice I didn't even put tick marks on it. I didn't do an XY axis arrow, nothing. I'm just going very, very simple when I draw this, okay? So just 3 quick examples, and I'm asking you, are these functions? Which one of these would not be a function? 1, 2, or 3? Number 2, right? Let me just show you why number 2 is not a function. So here we go. I'm going to start drawing a vertical line, okay? So, all right, that one touched right there one time. So far, it is a function, okay? So far, it's a function because I drew a vertical line and touched the graph at one point. But now let me draw another one. Notice that one touches at 2 points. And according to the definition, if it touches 2 or more, it's not a function. So I'm going to write not, or are these functions? I'm going to put no. And that's it. I'm just going to write no. Okay. What about example 1? Is this a function? Yeah, I mean, look, I'm going to draw one right here. It only touches once. I'm going to draw here. Only touches once. I draw here. It touches once. Another one here. It touches once. Is it going to be okay if I draw just one line all over the place? Is it only going to intersect at one point? Yeah. So this is a yes. Okay. What about that parabola, number 3? Is that a function?
Yes.
Yeah, it is. Right? Because I can draw a line there, and draw a line here, only touches once, a line there, only touches once, a line here, only touches once, only touches once. It doesn't matter where I draw it, it's only going to touch once. Some people say, wait, it touched the arrow. Well, the arrow's not really supposed to be there, right? That's just something we draw to say the line keeps going. But it's going to be fine, okay? So this is going to be a yes. So some of your homework is just going to be stuff like this. I mean, did you have to do anything mathematical in terms of adding, subtracting, multiplying, dividing? No, right? You're kind of just observing and making a decision. It is or it is not going to touch a vertical line more than once. Okay? So pretty easy, hopefully, right? Just yes and no. That's all you're saying. Yes and no. It is or is not. Okay? So remember, definition says you got to draw many vertical lines across the graph, and each one has to touch only once. The moment one of them touches more than once, that's it. Okay, not a function. All right? All right. So I got to write some definitions in the what is domain and what is range portion, but go ahead and write what is domain, what is range. And then we're going to talk about interval notation, which is at the very bottom, because we're going to start writing stuff a little differently. And that's going to be probably the hard part for the homework, is you remembering what means what. So that's why I'm going to give you guys a chart. But what is domain and what is range? So I'm going to give you the actual definition, well, actual-ish. I don't go all the way theoretical, but the mathematical idea, and then I'm going to give you like the hint, the way I think of it, right? For both of them. I'll tell you what the definition kind of sounds like for domain, what it sounds like for range, then I'll give you the little hints, and then use the hints. The hints are a lot easier to kind of ask yourself these questions. Okay? So, by definition, okay, domain, these are the x values that a function occupies. Meaning, every x value that it crosses, that's its domain. Okay? So if you look at a graph, you're going to ask yourself, what x values does it cross? Whatever those values are, that's the domain. Okay? So easiest way to think of it this way is like this. This is what I ask myself. How far left? How far right? I guess I can. How far left? How far right? This is the easiest way to do it. You're going to ask yourself, how far to the left did it go? How far to the right did it go? Okay? And once you identify that, hold on, I'm just trying to move this up really quick. Once you identify that, then just write it down. Okay? You also have to ask yourself whether or not it includes the points and stuff like that, but we got to get to an interval notation to talk about that. So what is the domain? Well, the domain are all the x values that the function has. Okay? How do you identify it? Ask yourself, how far left does the graph show? How far right does it show? Okay? Don't forget, guys, the arrowheads on the graphs means and it keeps going, right? It doesn't mean it stops there. It keeps going. All right? So what is range? Well, range is the y values that the function occupies. So the y values that a function occupies. So you're looking for what y values does the graph cross? Does it start at 0 and only goes up, right? Or does it start from -2 and end at +2? Like what is the range of y values? Okay? The way I think of it like this. How low? How high? In that order, by the way, okay? When I say how far left, how far right, literally has to be in that order. You got to do left first, right second, okay? For range, low to high. Have to do it in that order, or else you're writing it backwards, okay? Did you get it? There's a mosquito that's it's above me. Yeah, there's a mosquito in here that just doesn't want to leave. I've tried to get it, but I can't. But yeah, if you see it, knock it out. If it's on somebody though, don't just smack them. Let them know that they have it first. Then you can smack them if they let you. But all right, so how low to how high? All right. Now before we get into doing some problems, we have to talk about the notation, how you're expected to write this out. So this is interval notation. Okay. So for domain and range, you notice they almost look identical, right? For domain and range. But what's the difference with the way we write domain and range? What's the one main difference?
Domain has X values, range has Y values.
Yeah, domain has X values, range has Y values. But does the A and the B still basically stay the same? Yeah, do the symbols basically stay the same? Yeah, but this one's describing, domain is describing left and right motion. Range is describing up and down motion, right? From the bottom up, okay? And domain is from left to right, all right? The other thing you should notice, whenever you're writing interval notation, a parenthesis means it does not include the number, right? Notice A less than X less than B. That means it doesn't include A, it doesn't include B. But if you look at the interval notation, it uses parentheses. Now, they'll use a bracket. So look at the very bottom one. Bracket A, comma B, bracket at the end, right? Because it does include it. Look at the domain, look at the range. It uses less than or equal to, less than or equal to, right? It includes it. It says or equal to. So anytime you see a bracket, that means it includes that number, okay? If you see a parenthesis, that means it doesn't include the number you wrote. It includes everything after it and before it, but not those numbers themselves, okay? So parenthesis means it doesn't include the endpoints. That's what they're called, endpoints, the ends, okay? Brackets means it can include whatever the point happens to be. If the bracket's on the left, it includes a number on the left. If the bracket's on the right, it includes the number on the right. If it's on both, then it includes both of them, all right? So this is called interval notation. So I'll leave it up there for a little bit for you guys. Let me pause it. All right, so now that we have interval notation written down, every once in a while you're going to see some graphs where they draw you a picture and the lines go on forever. They put little arrowheads, right? Maybe they point to the left forever, maybe they point to the right forever, or pointing up or down forever. So we have to use infinity, okay? So when do we do it? Well, I just kind of mentioned it. When a graph continues forever. Okay, I'll draw you like a little example of something like this. Just a little tiny one. Nothing big. So if I do, let's say a dot, okay? So let's do that one. Give me a second. I'm gonna make a copy of this real quick. All right. So let's do a little practice run here. Okay. And by the way, whenever you use infinity, you could either have a negative infinity because that means that it's going either to the left or down. Okay. So I'm gonna put right here left or down forever. Okay? And if you use positive infinity, it's because it's going right or up forever. Okay? Or sometimes right and up because it's diagonal. Right? So the negative infinity is used when you're going like in a left or down direction, or maybe a downward left direction, a combination of both. And the positive infinity is when you're going right or up. Okay. My only warning for you guys on your homework, they're not going to let you put the symbol. You're going to have to write the word. So you're going to have to put like negative infinity. Okay. On your homework, you're going to have to write it like that, or positive infinity. Kind of sucks, I know, but in order to do the notation, you have to do all this extra work, so it's just easier to write the word. Okay? So on your homework, you might see that. So just write negative infinity, positive infinity. All right, so here we go. What is the domain? So we use a capital D like that, and then range, we use a capital R. Okay? What is the domain of this graph? In other words, how far left does it go? Think the x values. How far left? I'll kind of mark this off right here. Give me a second. I think I heard some people, but I wasn't fully paying attention. How far to the left does it go? To -2. Does it include the -2? Do you see a solid dot there or an open dot? Solid. So that means it includes it. So I'm going to say bracket -2. Okay. How far to the right does it go? Does it stop at a point, or do you see an arrowhead? Arrowhead. So that means it keeps going to the right. So what do I write? Positive infinity. So I'm going to do this, but remember, on your homework, you're going to have to write it out. Now, here's a real quick thing, just so you know, and it's a little hint. Infinities never have brackets, always parentheses. Okay, infinities always have parentheses. So let me put that on a little note right here. Infinity always use parentheses. Okay, never brackets. Because brackets means that brackets means that you can actually use that number like a 5. It's a finite value. Okay, it's an actual value. Infinity is not a number that we know what it is, so you can't contain it. Okay, so a parenthesis is always used. Okay, all right. What about range? How low does it go? Remember, it's low to high. How low does it go? Infinity, positive or negative? Negative, so all the way to the bottom. And remember, since we're using infinity, we're going to use parentheses. So negative infinity. How high does it go? +2. Does it include it? Or do you see like an empty hole up on the top? Or is it a nice solid curve? Solid curve, right? So we can include it. That's what your homework is going to eventually turn into. That part right there, the D and the R portion. You're just going to give me that information. Again, you're not calculating anything. You're just looking at a picture and saying, okay, it goes this far and this far, this far and that far. Okay? Are we okay with how to use infinity? So right now we're going to use everything. So go ahead. I don't know if you guys want to draw these, or if you just want me to do them and then you're like, I can look at the notes later if I really want to see the pictures. Okay, but I'll give you a couple minutes. The hard part is that you have to draw them exactly like I did so that it makes sense. And if your graphs aren't the same as mine, then when I do my answers, they're not going to match, right? So that's the kind of like the hard part. So I'm going to give you guys some time to do that. I'll pause the recording and then we'll come back to it. All right, so I just want to know what the domain and range are for these graphs. Okay, so number 4. Domain and range. Okay, I want to know the domain. So how far left and how far right does it go? How far left does it go? -2. Does it include it? Yeah. How far to the right? Positive 3, and that gets included. Whoops, that gets included as well, right? So, all right, we're good. How low does it go?
-4.
-4. Does it include -4? Yeah. How high does it go? +3. Is this difficult? I hope not. I hope not. I know the notation can be kind of tricky, but I hope the work isn't hard. All right, number 5, domain and range. Okay. How far left does it go? -2. And does it include it? Yeah. How far right does it go?
4.
+4. Does it include it?
Yes, sir.
Yeah. So if you want, you can now tell me 4 inclusive, right? Or 4 non-inclusive, right? In other words, it does include it, doesn't include it. What about range? How low? 0. Does it include it?
0.
Yes, right? And how high?
3.
3. And that would be 3 inclusive. All right, not too bad. Again, it's going to take you longer to draw the problems if you're doing it. All right, let's go to the next 2. These are going to change a little bit, so let me pause it. All right, so for number 6 and 7, I'm going to also try to figure out the domain and the range. Okay? So for domain, again, ask yourself how far left, how far right. So how far to the left did it go? -3. Does it include it? Is there an empty circle there? Yeah, so that means not included. Okay? The empty circle is not included, because or else it'd be a solid circle. That means it's part of it, right? How far to the right does it go? Infinity, right? Positive infinity. So remember, on quizzes, you're going to have to write the word, okay? Plus infinity. Make sure you spell it right, or else the program freaks out and it marks you wrong. All right. Range, how low does it go? -2. Does it include it? You see a solid circle there at -2? No, so then non-inclusive, right? And how high is it going to go? Positive infinity. I know some people say, how can it be positive infinity? It only went this high, right? Well, yeah, but remember, you keep drawing it, right? You're supposed to keep drawing it forever. So eventually it's going to reach the highest point possible, right? So positive infinity. All right, look at number 7, domain and range. All right, domain and range for number 7. How far left? Negative infinity. Negative infinity. Remember, infinities always have parentheses. How far to the right does it go? Positive infinity. All right, good. All right, here's the one that sometimes tricks people. How low does it go? Negative infinity. All right, nobody's getting tricked yet. Right now, I'll tell you what tricks people. How high does it go? All right, positive infinity. Now, why do people get tricked? Sometimes they say this is how high it went, this is how low it went. They see the high point and the low point, and they're like, oh, from here to here, just right there, right? But that's not the case. The arrows keep shooting up in an upward direction and downward direction. So there you go. So number 7, negative infinity to infinity for domain, negative infinity to infinity for the range. All right, last 2, and then we're done. I'm going to pause it again. So the last 2 problems here, I'm going to do domain and range for both. Whoops, not a highlighter. Sorry about that. So domain, range. I'm just going to write it down for both of them. Domain and range. All right. So how far left does number 8 go? Negative infinity. Remember, always parentheses for those infinities. How far right? +2 inclusive or not inclusive? Not inclusive, right? So there you go, parenthesis there. How low does it go? All right, negative infinity. How high does it go? Positive infinity, okay? So that's low and high. All right, domain for number 9. How far left? Positive 1, does it include it?
No.
No, both points at positive 1 are empty circles, right? And how far right? Positive 3, does it include it?
Yeah.
Yeah, it does. There's no empty gap right there, okay? So it does include it, okay? So there you go, 1 through 3. How low? Negative 3. Included or no?
No.
No. And how high? Included? No, it doesn't, right? There's a empty circle right there. So there you go. That's your domain and range.